All right. Hello, students. Good morning. Welcome to third period. Hello, third period. Say hello to everybody that's listening to the video. Yay, they're so excited right now that I'm recording in class. All right, so today we're going to be talking about correlation versus causation. Just because two things have a relationship or it looks like they are positively correlated or negatively correlated doesn't necessarily mean that there's a cause and effect going on. It just might be coincidence that they are, as one goes up, the other one is going down, okay? So today we're going to differentiate between regular correlation versus causation. Correlation is going to be talked about over here, whereas causation is going to be talked about over here. Clear? See the notes? Now, correlation implies a mutual relationship between two things. You see a pattern. Positively correlated, negatively correlated. But you need to understand, very importantly, that does not mean a cause and effect relationship. Okay? It could just be a coincidence. All right? Any other factors? So correlations are only going to show relationships, but we cannot make conclusions from them. Kind of like the one where the number of students at Dutchtown High School really has nothing to do with the number of dogs in Atlanta. Okay? So we can't say, oh, definitely 100% the number of students is causing the number of dogs in Atlanta. So, whereas causation is a relationship, it does imply a relationship which has a direct consequence, whereas one action affects the other, cause and effect. And we're going to run through some examples so you can kind of get a feeling for how to tell whether it's just correlation and how to tell whether it's causation. Okay. So looking at this example right here, we notice, I'm working with correlation here, the first one. We notice that when there is smoking, it is correlated, there's usually alcoholism. So we notice that there's a pattern there. People that smoke and tend to also drink, okay? Now, but it doesn't cause it. Just because you smoke doesn't mean that it's going to cause you to be drinking. Are we clear? It's just a pattern. They're just correlated. Whereas this one is causation because the more you smoke, the chances of developing lung cancer increases. This one does have a direct cause and effect. The smoking causes the chances of lung cancer to increase. All right, so you can ask the question, does smoking cause drinking? Not necessarily, right? So that's why it's just correlation. Does smoking cause lung cancer chances to increase? Yes. So this is cause and effect. Okay. Here's another example. The more ice cream consumed on the beach, the increased number of people that go in the water. So now you have to ask yourself, hey, does eating ice cream at the beach cause people to go into the water? No, so it's just a correlation. It's hot, that's probably why they're eating ice cream, okay? But this one will be cause and effect. The less calories you eat, the more weight that you lose. Does eating less cause you to lose weight? Yes. Okay? Any questions on whether it's correlation or causation? All right, so now we're going to do a quick study, and you guys will look at A. Let's do it together. A recent study showed that college students were more likely to vote. College students were more likely to vote than the peers that were not in school. Does being a college student cause the ones that are not college students to not vote? No, so this is just a correlation, okay? But it's not necessarily a cause and effect. They might be related, but it's not cause and effect. The next one says, Dr. Shaw noticed that there was more trash in the hallways after second period than first period. So is second period causing more garbage in the hallways than first period? Yeah. Okay. Now this one, some of these are kind of iffy. It might also be correlation. The other teachers we were kind of wondering. So, but this one definitely. You hit your little sister and she cries. What is this one? Causation. Are we clear? You caused her to cry. You hit her. No, no, no. We cannot hit our little siblings. Yeah. Enjoy while you can, because then they grow up. I'm just kidding. And some of them grow up to be bigger than you, and then it becomes a problem. What did you say, Blessing? I said that I really wasn't sure. I'm leaning towards causation, but you could make an argument, blah, blah, blah. So this is the thing about modeling, in that you're interpreting the data. So there's a likelihood, like the chances of it being right can increase or decrease, but then there's always that gray area in between. All right, how about this one? How about you guys do D and E? And I'll wait. I'll give you about a minute. All right. See if your peer or somebody next to you has the same answers as you. If they made the same conclusions, check right now. Hmm? All right. Let's come together. All right. The number of miles driven and the amount of gas that you used on your trip to Disney World. Yeah, the number of miles that you drove were caused by the amount of. Yeah, there's causation here. The more gas you use, the more miles you can drive. Okay. Hey, group. Third period. Third. All right. The age of a child and his or her shoe size. Wait. Let me ask the question. Does the age of the child cause the shoe size? But so you telling me you gonna stay at okay. So hey, focus and listen and learn. Come back to me. Okay, here we go. Can I explain it? So, you're thinking about the outliers. You're not thinking where most of the data is. Are we clear? So you're thinking about that situation that could be different from the rest. But in general, the majority of the time, the age of this child determines the shoe size. I told you so. Okay, so there is causation there, and yes, you're going to have outliers. Capiche? Thank you. It's causation. The younger the child, the smaller the shoe size. The older the child, the bigger the shoe size. Okay. All right, now this one. The amount of cars that the salesman sells and the amount of commission that, I don't know why the salesman has to be a he, saleswoman, I guess, like whatever, these examples. Amount of commission that he makes. Is this just correlation or is there causation? Yeah, correlation. Because he might
might not make nothing.
He might not make nothing,
He might not sell you cars.
but it says here the amount of cars that he sells and the amount of commission that he makes. So the way the salary of a salesperson works, the more cars he sells, the more commission he makes. So it's causation, okay? Not selling causes no commission. Selling cars causes commissions. Okay. Oh, this should be blank for you guys. So let's go here. All right, so now we're going to predict. Predicting means all right, so you must use the trend line. All right, and the trend line is the best fit line. So one of the things that I want to teach you is the first thing you want to do when you get a graph like this one is you want to understand it. What is on the x-axis? Average age. So it goes from 10 years to 100 years. What is on the y-axis? Watching TV, the minutes of watching TV per night. So it looks like the younger the age, they watch TV a lot higher. Then when you're older, you tend to watch less TV. That's what the graph is saying. Clear? So now, the question is, what can be concluded from the scatter plot? Which ones can we cancel and why? Which ones can we cancel and why? 10. It says A, B, C, or D. Okay, why A? It's not true, right? It's not what the data is saying. So, okay, what else can we cancel? It's not B, why?
Because we're not talking about that taste of changes.
Exactly. This is not giving us any information on their taste of TV, okay? So, we can take out D, why? Because there is a relationship, right? We can clearly see that it's trending downwards, right? So yeah, and then of course this one is correct. The graph does say that the older persons watch less TV. All right, now once again, when you get a graph, spend 5 seconds on the graph, seeing what is it telling you, so that it's a little bit easier to go through the word problems. What's on the x-axis? Fat. So we got 5 grams and 45 grams of fat. What's on the y-axis? So we're going from 0 calories to 800 calories. And what's the trend? Positive, right? We can clearly see that there's a positive trend, a strong positive trend, okay? All right, so let's read the question. The scatter plot shows the number of fat grams in a restaurant sandwich and the number of calories. So, makes sense? So I guess the more fat, the more calories, right? That's what it's saying. How many grams of fat would you predict to be in a sandwich that contains 650 calories? So for this one, for predictions, we need a trend line. And so you need to draw a trend line. You see there's 3 points here. So maybe somewhere between them here. These points, you want to be closer to the points. You still want to be a straight line. All right, so you want to evenly distribute them. You know, it might be a little bit up here. So something like that. So you want to make sure you're taking into account all the points. So the trend line would probably look like this. And since they're asking us to predict, that means we need to use this trend line. Because the other option, no, we would have to guess that. I would not. So I see. So where do we go first? You use what you know. Are we going to start at the x-axis or the y-axis? We're going to start at the y-axis and we're going to find 650 calories, correct? And then you're going to go towards your line, the trend line. Let me zoom in. And then from there, you're going to go down. I don't know. So what, 37? Between 35 and 40? Exactly. It will not be the same answer for everybody, okay? So yeah, so about 37 grams of fat. All right, for the next question, where are you going to start? It says, how many calories would you predict to be in a sandwich with 20 grams of fat? So are we going to start on the x-axis or the y-axis? On the x-axis, and then at 20 grams, so go to your, find 20 grams here. Get some color. Go up somewhere around here. See, I would say 490. So about 490, about 500 grams, you know? It's an estimate. We're predicting. Okay, dokie? I don't mean grams, I mean calories. Say it again. Yeah. Yes, if 490 wouldn't be a choice, then you would go with 500. If you said 500 but 490 was a choice, then you would go with 490, okay? And when it's something like this, like predicting, they tend to not give you choices that are too close to each other that you would have a doubt. Like it's very obvious which one it would be, okay? All right, over here. Yay, we need decimals for this. So let's go ahead and open up our decimals. All right, so everybody's ready with Google Classroom. So right now, the first thing is, we're not gonna plot this by hand because we have a graphing calculator, right? So you're gonna go to decimals. Oops, my email. Not my email, decimals. Whew. All right, so this time we have to create a table. So click on the plus sign, generate a table, then do your best not to mess up the numbers. Now I use the enter key. I do my X's and I go down. That way I'm not going back and forth with the arrow keys. 671. 2717. Okay. And so this is another check to see whether I missed a number because I should enter the same number of Y's. So it'd be 80, 90. Okay. Thank you. All right. No. Yes. Should I put it in the video? Just stop instigating, okay? No need to instigate. Yeah, so then now what you're gonna do is, we did this before. We're gonna, after you create the table, remember this table says X1, Y1. So I'm gonna use X1, Y1, and then in decimals, let me change the pen. You're gonna type in Y1, the tilde symbol, MX sub 1 plus B. And please write it down. So you're not always asking me, what do I type again? What is wrong with it? You know who sounds like that, so there we go. All right, so then here you do Y. Then you open up the keypad, ABC, And you use the A sub B, the little A with a little b, and that puts you in the subscript area. You put a 1, but now you need to exit the subscript area. We use the arrow key. We do MX, same deal. You got to use this one. Ooh, I made a mistake. We're supposed to use the tilde, not the equal sign. My bad. So the tilde sign is right here on the keypad. Don't forget the plus B because it needs to also give us the y-intercept. And so, can't quite see it, but there it is once I zoom in. I mean zoom out. Let's see. So in this case, R is equal to, let me use something smaller. I don't like going from tab to tab, as you guys know. Okay, so R equals 0.8548. Right, so that tells you that this is a strong positive correlation. Our M is 6.27. I'm going to round to the nearest hundredth. So let me write that down. And B, the 7 is going to round up, so 49.78. All right, so the trend line, or the best fit line, is going to be y equals 6.27x plus 49.78. Okay. Please stop making so much noise in the background. All right, that's the trend line. Remember, when you write this is an actual equation, so there's no more subscripts on the y and on the x, and there's no more tilde. We go back to the equal sign. And so this line is this black line on our Desmos. And you'll notice the data doesn't fit the trend line perfectly. The data points are the actual data, and the trend line is what we use to predict. Okay? So far, so good? All right. Now, this one gave us a good trend line. 0.85 is pretty strong. So now we're going to work with this one, and this one is going to give us what happens when we have an outlier. So I probably shouldn't have done that. There we go. So I'm just going to get rid of this data, and backspacing gets rid of all just backspace. So I'm back over here. Okay. I'm going to type this in, and once again, I like to go type in all my X's first because using the enter key takes me to the next line. So please model along. So this is pre-modeling, because you didn't have to go out there and get the raw data. The data is being given to you, and it's more structured, but we're trying to make sense of this information. We know that those are the TV hours per week, and those are the test scores. Is there a pattern to it? When you just look at the data like this out of order, can't really quite make a pattern, okay? Can't really see it. So we're going to model it. So first I'm going to create the table. All right. Please, make sure you're following along. Let me see, 30, 60, 1280, 3065, 2085. Let me pause. All right, so I finished the table. I'm back, and I put in the data. I didn't have to retype this because I just replaced the numbers in the table. So it just recalculated on its own. And lo and behold, I'm gonna zoom out so you can see that doesn't even look like a good trend line, right? Right, what's the R value? The R value is really, really bad. Negative again, basically. Yeah, R squared is 0.0004, and this one is the R is negative 0.02. Okay, that just tells you that it's no correlation whatsoever. Clear? We can see it that our fit line, our best fit line, our trend line is not modeling the data at all. So what is going on? The outliers are causing this. Which one is the outlier? Which data point is the outlier? Exactly, 1010. This one right here is this green point over here. It's, as you can see, something must have happened. Somebody recorded the information wrong. Clear? So what I'm going to do is now watch what happens when I get rid of that data point. Okay. I go to where the 10 is. You see the mouse right here. I click on here and I hit the backspace. I hit the backspace again and it takes me to the other column. I hit backspace and I still have that empty row, so I hit backspace to get rid of the row, okay? And then stop hitting backspace. And then now it looks like our trend line is modeling it better. Let's look at the R. So after we get rid of 1010, all right, the new correlation coefficient, look, is 0.63. We'll take the R squared. I don't know why I was taking the R before. I'm sorry. I'm taking the R squared. It's 0.63, which, is that strong? Negative? It's not strong, but it's close to being strong, right? It's a strong moderate. Yeah, so it's moderate, but it's a stronger, plus it looks pretty good. But if you zoom in, you can see how far away the data points are from the trend line, right? So it's moderate, but it's much better than zero. All right. Do you all understand what I meant by outliers? Okay. Now, here's a test. It's a matching game. All right, we have these choices right here. Clear? We have 0.45, 0.94, 0.07. Oh, it should be R squared. Negative 0.39, negative 0.89. Which of these is a strong correlation? All right, 0.94 is strong, positive or negative? Okay. Which is another one that is a strong correlation? Exactly, this one over here, because it's close to -1. So it's a strong negative correlation. Remember, 1 and -1 are good, 0 is bad. Okay, so with that in mind, which one is a no correlation? All right, somebody else? Now want to volunteer information? No? Okay, so we'll take Chris, no correlation. Right here. Okay. And this one would be moderate positive. Do you know what I'm talking about when I say moderate positive, moderate negative? Strong. Everybody, do we know what we're talking about when we're saying strong, moderate, no correlation? Because that was yesterday's lesson. Okay. Now, match them.